All right, let's go second part of this chapter, and this will be the longest video, or the longest lecture, I guess. There's two short ones and one long one, so we'll try not to spend too much time on this, but we're going to talk about the subdivisions of the digestive tract. So all of the structures and organs needed to ultimately digest and absorb nutrients from food. So we'll start in the oral cavity, talk about teeth and tongue, and then head into the throat, the pharynx, which we've talked about, in the respiratory system. So we won't spend too much time there because the pharynx is shared by the respiratory and digestive systems, but its job is to just help move food forward. Esophagus, stomach, small and large intestine. So we'll get through all of those structures as we go. There's a figure of them here that we've seen before. Let's talk about the functions of the digestive system, or the tract. Ingestion, obviously taking food in. Mechanical processing, which is basically chewing, mashing, crushing, and shredding food in the oral cavity, and churning it in the stomach. So there's mechanical processing in the mouth and also in the stomach, because there's lots of muscle there that helps move food around. Digestion is actual chemical and enzymatic breakdown of food into smaller molecules like carbohydrates, fats, proteins. Secretion happens to help that process along of digestion, and absorption of molecules, electrolytes, vitamins, macromolecules like glucose, carbohydrates, fats, proteins through the intestinal lumen, from the intestinal lumen into the bloodstream. And compaction and defecation is the process of excretion, basically. So in the oral cavity, there's oral mucosa, which is lined by stratified squamous epithelium, and these cells are keratinized, like what you would find on the surface of your skin, and that helps prevent abrasion and damage to the tissue that's underlying this epithelial tissue. You have some cells that are keratinized and some that are not, that line like the cheeks, your lips, and the inferior portion of your tongue, where abrasion isn't nearly as likely. The teeth crush and shred food in a process called mastication, which is chewing. And then digestion of carbohydrates and lipids actually starts in the mouth, in the oral cavity. So take a look here. You've got the roof of the oral cavity, superior portion, that is separated from the nasal cavity by the palate. And there's hard palate, bone, and soft palate, which is other tissues, that ends at the uvula, that little hangy ball thing in the back of your throat that you can see. There's one example of a tonsil here. Two examples, that we'll talk about here shortly. There's a tonsil and here's a tonsil. Tonsils and glands on figures and models kind of look like chewed up gum to me. So that's where you would see like a glandular tissue. There's your cheeks and your tongue, and then teeth and your lips are what create the oral cavity in general. So let's talk about those structures. The tongue basically manipulates food in your mouth. Again, there's some structures that are shared by the respiratory system, because your tongue helps you articulate sound into words. But there's also secretions, an important secretion where lipid digestion begins, called lingual lipase. So think lingual as tongue. That surface is flushed by secretions that help start chemical digestion. And the gingiva, or your gums, are basically what help protect the base of each tooth. And that's bound to the periosteum, the outer layer of bone that underlies that, like your maxilla and mandible. So in parts of a tooth, so let's talk about that. A tooth is mostly a structure that's similar to bone. So it's similar to mineralized matrix in bone, but there's no bone cells like osteocytes or osteoblasts or osteoclasts. So that tissue is called dentin. It's the bulk of the tooth, but inside that dentin is a pulp cavity, which is in the interior chamber. And there's three sections of every tooth. A crown that you can actually see, the kind of white, pearly white part that you can see when you smile is your crown. The neck is between the crown and the root, which is right at the base of your gums. And then the root is everything that you can't see in your tooth, which is below the gingiva, and it resides in a tooth socket called an alveolus. So every tooth has one alveolus where it resides in the bone of either the maxilla or the mandible. And there are sections of the tooth or components of a tooth, like enamel, that covers the crown. Remember, the crown is the exposed part that you can see when you smile. And that enamel is important in protecting the dentin of the tooth. So if you've ever heard a dentist say you're wearing, like if you grind your teeth, you're wearing your enamel away, that exposes some stuff underlying that enamel in the dentin that can make the tooth sensitive or can cause decay. Cementum is what covers dentin, but in the root of the tooth. So everything you cannot see. And that helps basically attach what's called the periodontal ligament to the alveolus, the bony socket that the tooth sits in. And that periodontal ligament is mostly composed of collagen fibers. And your root canal is a passageway for blood vessels and nerves to reach the pulp, which is just a narrow tunnel in the root of the tooth. So take a look here. The crown is everything exposed, right? Remember that pearly white part? The root is where the gingiva, the gums basically connect here, and is the connection between the crown, the neck, not the root. And then the root is everything that you cannot see. And the root is where the dentin is basically anchored and connected to the tooth socket. So this tooth socket created by the bone in either your maxilla or mandible is the alveolus. So right here's your pulp cavity where there's blood vessels and nerves that supply blood to and innervation to the dentin of the tooth. And then the root canal is the canal that those vessels use to make their way into the pulp cavity. So look, when you wear the enamel away on your tooth, you can then expose the dentin and even sometimes some of the pulp cavity or the nerve endings that make their way up into this dentin and make your tooth really sensitive. And remember that the periodontal ligament is this ligament that basically attaches to cementum that anchors the tooth into the socket. There's 4 types of teeth. You have 4 different types of teeth because they have different functions. So incisors, you have a central and a lateral incisor on each side of your mouth, top and bottom. So we're going to go just kind of from the very middle of your front teeth, 2 front teeth. On either side, there's a central incisor. And then if you follow them to the next tooth over, there's a lateral incisor. They're blade shaped because they're able to cut and clip food. Cuspids or canines are the pointy ones that are conical in shape, and they're used for tearing food. Bicuspids or premolars are just beyond that, and they're flattened to help start to mash and grind food. And then molars are even larger and flattened that help crush and grind food as well. And they've got typically 3 or more roots as opposed to a bicuspid that has only 2 roots. Think 2 roots. So take a look. So there's a bicuspid with 2 roots, right? Canines are pointy, incisors are flat, and then molars have 3 roots. And there you go. There's central and lateral incisors, a cuspid or a cuspid or a canine, and then this is a child's mouth because there's only premolars. There's no molars down yet. So there may be another figure in chapter 15 here that has an adult mouth. This is a child's mouth. So central, lateral incisor, cuspid, and then the molars. There should be another set of molars here, but this is a child's mouth. Tooth decay is typically the action of bacteria in the mouth. They adhere to the surface of your tooth and can produce deposits called dental plaque. And then that plaque buildup over time can cause a weakening of the gingiva, resulting in gingivitis, which is an inflammation of the gingiva. The dental plaque can stay on teeth. Gingivitis is an inflammation of the gums. But regular brushing and flossing helps remove that plaque and prevent tooth decay. So basically, over time, if you're not brushing your teeth, especially if you're not flossing, food gets stuck there and it'll stay there and cause plaque. So if you've ever been to the dentist where they're just digging in between your teeth with that metal pick, they're picking off dental plaque. And you can prevent some of that discomfort by just flossing your teeth at least once a day, hopefully several times a week. Remember, as you eat, every time you eat food, some of that food gets stuck between your teeth, and a toothbrush doesn't always get that out. So flossing is really important. Your pharynx is basically from the back of your nasal cavity to your mouth. We've talked about the three sections, the nasopharynx, the oropharynx, and the laryngopharynx, but that's continuous with the esophagus. So it's a common passageway for food, liquids, and air. So it's actually shared by the respiratory system and the digestive system. The nasopharynx is predominantly only utilized to move air unless you accidentally move food in the wrong direction. So the oropharynx and laryngopharynx are shared by the digestive and respiratory systems. The nasopharynx is predominantly a structure in the respiratory system. So here's your three sections, right? So food shouldn't get up into the nasopharynx, but if you cough or something happens while you're eating, sometimes you can get food moving in the wrong direction. It's very uncomfortable, but it does happen. And then the oropharynx here and the laryngopharynx are part of the throat that is continuous with the esophagus here. And then as you breathe air in, air is supposed to move here into the windpipe, your trachea. And when you swallow food, the epiglottis is a major structure that folds over the opening of the larynx, the glottis, so that food can continue down the esophagus and not get into the respiratory system. So the esophagus is hollow and muscular. It transports food and liquid from the pharynx to the stomach. So its major job and really only job is to move food and liquid, transport it from where you consume it in your oral cavity into your pharynx where you swallow it, and then carry it to the throat or carry it to the stomach. It doesn't really have, it has a very, very thick epithelium. So no secretion or absorption really happens here. Take a look. This is the really thick layer of stratified squamous epithelium that you can find in the esophagus. So it still has the three major layers. The mucosal layer, which is this between these two layers here, or between these two ticks here. And you can see this is a larger view of just the mucosal layer. So epithelium, the lamina propria here, and then the muscularis mucosa. Those three layers are right in here, all the way to this kind of dark to light transition line. And then you've got submucosa, dense irregular connective tissue, and then the muscularis externa, and there's one layer and another layer. So it's still the three major layers. The epithelial tissue is just what's different here from the rest of the digestive system. In the esophagus, you have two sphincters, an upper and a lower esophageal sphincter. And sphincters in your body are just round circular layers of smooth muscle that can constrict and dilate to regulate the movement of food beyond that sphincter. So usually the upper esophageal sphincter is in the uppermost portion of the esophagus, and that functions to prevent air from entering the esophagus. So it will close off as you swallow food and prevent the movement of more air into the esophagus, which can get trapped and cause gas, basically, in gas buildup in the digestive system. The lower esophageal sphincter is at the junction of the esophagus and the stomach, and that prevents the movement of food back up into the esophagus once it reaches the stomach. So it keeps food moving forward and doesn't allow it to move back. The stomach has 3 layers of muscle in the muscularis externa as opposed to 2. And it's got several sections. There's a lesser curvature that forms a medial surface and a greater curvature that forms a lateral and inferior surface. So the combination of food, saliva, and then secretions in the stomach form what's called chyme. So this is where majorly a lot of chemical digestion is occurring. And here's the sections of the stomach. The fundus is the uppermost portion. There's a cardia, which is the superior portion, but medial. And that contains a lot of mucus glands that protect and basically coat the connection with the esophagus to keep the esophagus safe and healthy as stomach acid is secreted, so that the lining of the esophagus doesn't get worn away. The body is the largest region between the fundus, the superior portion, and the pylorus, which is the inferior, more distalmost portion. It's like the J curve there is the pylorus. And at the distal end of the pylorus is the pyloric sphincter, which regulates the movement of food, this chyme that's being produced from the stomach into the small intestine, which is the first part of the small intestine is the duodenum. So take a look here at the lesser curvature of the stomach, the greater curvature of the stomach, which is lateral and inferior. And right here is the esophagus, the junction with the where the lower esophageal sphincter would be, at the junction of the esophagus and the beginning of the stomach, which is called the cardia here. And then the upper curve is the fundus. This large section is the body. And then just this J shape here is the pylorus. So this is the duodenum, the beginning of the small intestine. So right here would be the pyloric sphincter. Within the stomach, there are folds, just like we talked about folds in the small and large intestine. And those mucosal folds, the folds in the mucosa, are called rugae. And they allow for the stomach to expand as it fills and flatten out, and then recoil as the stomach empties and moves food forward. And the ability to do that is related to 3 layers of smooth muscle in the muscularis externa. There's a circular and longitudinal layer, just like in the esophagus and the small and large intestine, but there's a third layer, oblique layer, that basically strengthens that wall and allows for churning needed to form chyme. So here is these inner folds are rugae, and then you've got a layer of longitudinal muscle, circular muscle, and then a third layer of oblique muscle. Right here would be the pyloric sphincter. So this is the pylorus of the stomach here, the J, and then the duodenum, the beginning of the small intestine. The stomach wall, the inner components that have rugae, those big folds. In the mucosa layer is simple columnar epithelium. And that simple columnar epithelium, deep to that, there's mucus cells kind of strewn throughout that simple columnar epithelium that produce a layer of mucus, so that as stomach acid is produced, it's literally hydrochloric acid. So it's an acid, it's really, really acidic. So to prevent damage to the epithelial tissue that is regenerated constantly, there's mucus production, and that helps protect those cells against the acid and enzymes from being destroyed that are being produced there. And those enzymes and acid are being produced to break down food, but the mucus there is there to protect the epithelial tissue so that it can continue to do its job and stay healthy. So there's a simple columnar epithelium, and the rugae, these big folds, right? Within the glands of the stomach, so these glands in the fundus and the body of the stomach, so the upper curvature and the large portion of the stomach, mostly secrete acid and enzymes that can continue to digest food. But there's 3 different types of cells. There's parietal cells that secrete a factor called intrinsic factor that's necessary to absorb vitamin B12. But these parietal cells also secrete the stomach acid, so hydrochloric acid, really, really important cells that help digest and chemically break down food. There's other cells called enteroendocrine cells. So the enteric system, I think enteric is digestive system. So the enteroendocrine cells produce hormones. There's a hormone called ghrelin, which is a hunger hormone. When you haven't eaten food in a long time, ghrelin gets produced from these cells and tells your brain that you need to eat food, that you're hungry. So there's important hormones that are secreted from the stomach. Chief cells are another type of cell that secrete enzymes. So parietal cells secrete stomach acid, hydrochloric acid, and a factor called intrinsic factor. Chief cells secrete digestive enzymes like pepsinogen, which is activated by hydrochloric acid to pepsin, which helps digest proteins, so break down proteins into amino acids. And then renin and gastric lipase, so think lipase, lipid, helps break down lipids as well. So here's the cells. You can usually find some of them strewn throughout the epithelial tissue. You can find some of them deep to the epithelium in the lamina propria. There's parietal cells, there's chief cells, and enteroendocrine cells that can secrete hormones. Intestinal villi we've talked about. These are little finger-like projections that are line a circular fold, plicae circularis, right? So villi, again, are lined by epithelial cells that have microvilli. So the simple columnar epithelium that lines each villus, that is the mucosal epithelium, also have microvilli, and that increases surface area and maximizes absorption 600-fold. It's incredible how much surface area you have in your digestive system. On to the small intestine. There are 3 sections, from proximal, middle to distal: the duodenum, jejunum, and ileum. The duodenum is very short compared to the other 2. It's only about 25 centimeters long, but it's incredibly important. It receives chyme from the stomach, but also receives secretions from both the pancreas and the liver that help digest carbohydrates, fats, and proteins further. So it may not be very long, but it is incredibly important. We'll talk about where those secretions enter and where they enter from here as we go, because we'll talk about the pancreas and the liver. We'll talk about the accessory organs in the next lecture. The jejunum is mostly involved in chemical digestion and nutrient absorption. It's about 2.5 meters long, which is crazy. I think a meter is about 3 feet. So you've got 6, 7, almost 8 feet of jejunum, and then the ileum is 3.5 meters long, even longer. So think about that. Almost 6 meters you have of small intestine just smashed into your stomach region, into your abdominal cavity. And that ileum ends at what's called the ileocecal valve, which is another kind of sphincter that controls the movement of digested food from the ileum to the first part of the large intestine, which is called the cecum. So ileum, cecal, cecum. The ileocecal valve separates the ileum from the cecum, the first part of the large intestine. You can see right here's the duodenum, takes a turn. The jejunum is this smashed section in here, and then the ileum is the distalmost portion that ends here at the ileocecal valve, right? This kind of pouch here is the cecum, the first part of the small intestine with your appendix there. So the large intestine, the small intestine, its job is to absorb nutrients, carbohydrates, fats, and proteins. That's the major job of the sections of the small intestine. The large intestine, once all that is complete, really helps absorb vitamins that are produced by bacteria in the colon. So the colon is the same thing as the large intestine. Exchanges water, so reabsorbs water from the intestine, compacts indigestible components and creates feces, and then stores that feces prior to defecation. So the small intestine, its major job is to absorb nutrients. Large intestine, vitamins, electrolytes, and water is that the balance of those materials, those substances, happens in the large intestine. The cecum is the first part of it. It's an expanded pouch where the ileocecal, just past the ileocecal valve. And that's the process of compaction begins. The appendix is attached to the cecum. It functions mostly as a lymphatic organ and can get inflamed, but it doesn't really have much. There's a very small amount of lymph tissue located there. But it can get infected. There's a cancer of the appendix that's very rare. So it doesn't necessarily have a huge job, but it can cause problems. And then the other 2 regions of the large intestine are the colon and the rectum. So you've got the cecum, this pouch, right there's the ileocecal valve, where the ileum meets the cecum. The ascending colon, where there's a flexure, that basically it flexes, takes a turn, the right colic flexure. The transverse colon, where there's a left colic flexure. And then the descending colon, the sigmoid colon, there's a sigmoid flexure, like an S curve, there's a sigmoid colon, and then rectum. So there's sections of the colon, in addition to just the cecum, colon, rectum. The colon has ascending, transverse, and descending, and also sigmoid sections. It's listed here with the actual flexures. On the colon, in the colon, throughout the colon, there are 2 structures that are important. One is called the tenia coli, and that's basically 3 bands of longitudinal smooth muscle. In the muscularis externa, the longitudinal layer of muscle in the muscularis externa is called the tenia coli. So it runs along the outer surface of the colon, just deep to the serosa, which is the visceral peritoneum. And that the contraction of that muscle creates pockets or pouches called haustra that produce internal folding in the intestine. And that's basically created by the muscle tone of that tenia coli. But it allows for expansion and elongation of the colon. So I'm going to actually flip back to this figure, because this figure shows you the pockets, the haustra. Each one of these pockets, 1, 2, 3, 4, all along are haustra that are created by this longitudinal layer of muscle here, which is the tenia coli. I think it's pointed out, yeah, on this side of the slide. There's the tenia coli, and there's pockets of haustra. I don't know what's going on here. Let me back to my, I don't want to resume share. There we go. Sorry about that, guys. I'm right back at it. And we'll go back to here. The rectum is the basically expandable for temporary storage of feces, but that also triggers the defecation reflex. So the rectum is the distal end of the digestive system, period, part of the large intestine. And basically distension in veins in the walls of the rectum can cause what's called hemorrhoids that can cause really big problems. All right. Control of digestive activities. So we're going to really talk about function here as we go from this point forward. So parasympathetic activation by way of the vagus nerve, which is one of the 12 cranial nerves, stimulates production of gastric juices. Food in the stomach, by way of physical distortion, stimulates gastrin secretion. And then chyme that's produced in the stomach heads into the duodenum, where digestion and absorption occur in the jejunum and then ileum. Water is reabsorbed in the large intestine. We've mentioned this already. And then peristalsis basically forces feces into the rectum so that defecation can occur by way of a reflex, basically a stretch reflex. So these steps here are basically how food is moved and digested along the digestive system. So in response to sight, smell, or taste, even the thought of food, go back here, stimulates the vagus nerve to start producing gastric juices. It's almost like a preparatory phase. Gastrin causes parietal cells to start secreting gastric acid, hydrochloric acid, HCl here, but also stimulates gastric motility to increase, where muscle contractions are increasing in intensity. That gastrin, when food arrives in the stomach, basically the stomach has been prepared for that food to arrive so it can digest and break it down, where chyme is produced in the stomach and then sent into the duodenum, which triggers an enterogastric reflex, which basically inhibits gastrin production from that point forward. And that once food has made its way into the duodenum, it no longer needs to, the gastric reflexes no longer need to occur. That material arriving in the jejunum is broken down further by digestive enzymes, and the intestinal epithelium absorbs the products of that digestion in the small intestine, right? Digestion, nutrient absorption occurs here. In the large intestine, water reabsorption occurs, and electrolytes can be balanced back and forth across these membranes. And then basically as food makes its way completely digested to the rectum, it stretches and causes basically a reflex where feces are ejected. All right. So we're done with this portion of the digestive system. We will now head into the last section where we're going to talk about accessory structures of the digestive system. So I'll see you then.